Today's learning target for lesson U2A10 is I can write a recursive geometric equation. And by the end of class, what we're going to be able to do is start our homework, hopefully get much of it done this evening, in which we're going to be finding the recursive formula, and not just that, we're going to have to find the next 5 terms. Okay, so we're going to be doing this in just a moment. This is going to make a little bit more sense momentarily. First, however, let's do a little bit of a review. So today we're learning about recursive geometric equations. In our last class, we talked about recursive equations for arithmetic sequences. And what is the formula, the equation for an arithmetic sequence? It is, of course, a sub n equals a sub n minus 1 plus d plus the difference. And essentially, this is what? Well, we know that we need to know the difference. We also need to know the first term. And so the way this works is it's the previous term plus the difference. How is this different from what we're learning today? And what is exactly a recursive geometric equation? So right now what you're going to do is you're going to write this in your notes. This is super important. It is a sub n equals a sub n minus 1 times r. R is the ratio. And we're going to need to know the first term, which we're going to be referring to as k. So please jot this down and give it a little star because we're going to be returning to it in the coming days and on upcoming assessments. What is R and how is it different from D? How is the ratio different from the common difference? Well, we know that's the same number that we're going to be multiplying to each term as we find subsequent terms in the sequence. So let's explore this further. Let's take a look at this problem. It says, given the recursive equation, find the first 5 terms. How do we do that? Well, when we're taking a look at it, I can see that we've got the ratio. I also see that we've got the first term, and we just got acquainted with our new recursive geometric equation. So how do we start? Well, right off the bat, of course, we've got our first term. So I'm going to write a sub 1 equals 64. But what is a sub 2? A sub 2 is going to be the first term, which is 64, times what? Times 1/2. And 64 times 1/2 is going to give us, of course, 32. Meaning that a sub 2 is 32. Beautiful. What's the third term? A sub 3 is now 32 times the ratio, which is 1/2. And that, of course, is going to give us 16. So we're multiplying by 1/2, which is the same thing as dividing by 2. What's the fourth term? The fourth term is the third term, which is 16, multiplied by 1/2. That's going to give us 8. And finally, what is a sub 5? That's going to be 8 times the ratio, and that's going to give us 4. So this is a little bit formulaic, but we were able to successfully find the first 5 terms. So our objective now is to write a recursive equation for the following sequences and then find the next 5 terms. To find subsequent terms using the recursive formula, we need to know 2 things. We need to know the first term, which we have, but we also need to know the ratio. And how do we figure out what the common ratio is? Well, I remember that we've got that formula, right? It's a sub n divided by a sub n minus 1, which is the same thing as one term divided by the previous term. So let's say that we're going to use 15 as an example. It's going to be 15 divided by 3, and that, of course, is going to give us 5. So 5 is our ratio. Tremendous. Alternatively, we could have done, 75 divided by 15 or 375 divided by 75, and that would have all given us this ratio of 5. Beautiful. So our next step is to write the recursive equation. We've got the first term, we've got the ratio, and this is going to look a little bit like a sub n equals a sub n minus 1 times 5. And a sub 1 in this case is 3, but what we're going to do is we can do a sub 4 because this is the last known term, and this is sort of a jumping off point for the next 4 terms, for the following subsequent terms. So a sub 4 equals 375. This is good for our recursive formula. Beautiful. And I'm going to circle this just so I can come back to it. How do we figure out what the next 5 terms are? Well, I know that A sub 4 is 375, right? What is a sub 5? A sub 5 is going to be the previous term, 375, times what? Times 5, because that's our ratio. And what is that going to give us? 375 times 5, if you plug that into your calculator, is going to give you 1875. Great. And what's the sixth term? Well, the sixth term, a sub 6, is the fifth term times the ratio. So it's going to be 1875 times 5, giving us the grand total of 9375. Beautiful. What's the seventh term? It's going to be the previous term, 9375 times 5, and that's going to give us what? 46,875. Beautiful. And let's do one more for good measure. What is the eighth term? That's going to be the previous term, which is 46,875 times the ratio. You're going to be multiplying by the ratio each time. And that's going to give us what? 23, 43, 75. So what you guys are going to do is you're going to find one more term. So we've got 1, 2, 3, 4, 5. And you're going to make sure that you've come really well acquainted with this recursive equation formula. If you feel like you're still having some difficulty, you're going to go to the homework lab, or you can find Mr. Chan or myself during office hours. So let's do one more. We know that we need the first term, which we have. We're also going to need to find the common ratio. To do that, we're going to take one term and divide it by the previous term. So let's just say it's, for example, 132 divided by negative 1/8. And that's going to give us, of course, negative 1/4. Beautiful. So we know the ratio. We know the first term. What does the recursive equation look like? It's going to look a little something like this. A sub n equals a sub n minus 1 times negative 1/4. And we're going to be using the fourth term as our jump off for identifying subsequent terms in this sequence. So what's the fifth term? Well, the fifth term is the fourth term times the ratio, which is going to give us 1 over 512. The sixth term is the fifth term times negative 1/4. Seventh term is the sixth term times negative 1/4, and so on and so forth. Ladies and gentlemen, this is how you apply the recursive equation sequence. You're doing great work. Let me know if you have any questions. Good luck. And for tonight's homework, we're going to complete U2A10, write a recursive equation for the given sequence, and predict the next 5 terms.